Some 2.7 billion miles from Earth, summer has arrived on the south side of Neptune. But this isn't the summer we're familiar to. Do you guys know Neptune takes around 165 Earth years to finish an orbit around the Sun? Which means each season lasts for 40 years. That's roughly 160 times longer than one of our seasons. In comparison to our home planet, which heats up in the summer for picnics and beach outings, that world appears to be cooling down. Only one spacecraft has ever visited far-off Neptune. NASA's Voyager 2 probe brought back amazing pictures of this dynamic world in 1989, including an Earth-sized storm with 1,000-mile-per-hour winds. Since then, planetary scientists have used massive telescopes either on orbiting Earth to study Neptune, the planet farthest from the Sun. And they've witnessed dramatic changes in the planet's atmosphere over the last few decades. Average temperatures in Neptune's stratosphere, a large layer of atmosphere above the storms, and weather fell by 14 degrees Fahrenheit between 2003 and 2018. But here's where things get strange. Between 2018 and 2020, stratospheric temperatures in the South Pole unexpectedly rise by 20 degrees, which they claim has never been seen before at the windy orb's poles. It's very unexpected, Glenn Orton, a planetary scientist at NASA's Jet Propulsion Laboratory and one of the study's authors, told Mashable, "A lot of strange things are happening on Neptune that we don't understand." The findings were recently published in the journal Planetary Science. The graph shows a significant drop in temperatures, followed by a sudden rise after 2018. Because Neptune orbits Earth at a distance of 2.8 billion miles, astronomers measured the planet's temperature change by observing fluctuations in its brightness in an infrared light wavelength that isn't viable to the naked eye. The dramatic changes are unexpected because they occurred during a very long Neptunian season. Neptune, like Earth, rotates on a tilted axis and thus experiences significant seasonal changes due to differences in sunlight. According to Orton, scientists expected such extreme temperature changes to occur during different seasons. However, they are now taking place during Neptune's southern summer. Furthermore, researchers predicted that temperatures would gradually rise rather than fall significantly during this long summer. The researchers focused on Neptune's stratosphere, which is the upper part of the planet's atmosphere just above the weather layer. During the 17-year period, Neptune's stratosphere temperature dropped to minus 117 degrees Celsius, a drop of 8 degrees. Temperatures in Neptune's troposphere, the even colder weather layer, showed no significant changes. Temperatures in the troposphere reached minus 223 degrees Celsius. This was an unexpected change, Michael Roman said of the stratosphere readings. He is a postdoctoral researcher at the University of Leicester in the United Kingdom and the study's lead author. "I think Neptune fascinates many of us because we know so little about it," Roman added. However, Roman does offer a few solutions to Neptune's summertime temperature confusion. Temperature variations may be related to seasonal changes in Neptune's atmospheric chemistry, Roman said. However, random variability in weather patterns or even a response to the 11-year solar activity cycle could have an impact. Roman said the finding seems to be a general lesson that nature teaches scientists again and again. In other words, Neptune's thermal shenanigans could be the result of pure coincidence, periodic variations in the sun's activity, or even changes surrounding our host star's sunspots, where magnetic fields are unimaginably strong, like over 2,000 times that of Earth's. The European Southern Observatory, ESO, said in a statement that astronomers collected Neptune's temperatures using cameras equipped to measure infrared light from space objects. The ESO's Very Large Telescope in northern Chile was used for the majority of the team's observations. The temperature fluctuated unevenly over time. The southern tropics of the planet cooled, then warmed, then cooled again. Temperatures in the middle areas remained consistent before beginning to fall over time. Temperatures at the South Pole dropped only slightly for the majority of the time, according to the researchers. but then the temperatures rose quickly and sharply. I believe the overall temperature drop is due to changes in atmospheric chemistry, which responds to changing seasonal sunlight, Roman explained. According to Glenn Orton, Neptune may teach us about planets beyond our solar system known as exoplanets. The close relationship that Neptune may have with a large portion of the exoplanet population suggests that it could be an exoplanet in our backyard, Orton said. He went on to say that Neptune could become a model for what we might expect to see in the meteorology of future exoplanet studies. Not only this, there are a lot of unanswered questions about the blue planet. Here are some of the top queries like, why are the winds so fast? Neptune is a world of fast winds. They've been caught going about 500 meters, which is 1,640 feet per second, according to Simon, a senior scientist for planetary atmospheres at the NASA Goddard Space Flight Center. This is roughly 4 times the speed of Jupiter's fastest winds. According to NASA, Neptune's winds can reach speeds of up to 1.5 times the speed of sound, or 1,770 kilometers per hour at high altitudes. Also, for some reason, the winds on Neptune are blowing westward, or backward relative to the planet's rotation. According to research published in the journal Nature in 2013, the winds on Neptune and Uranus would be in the thin layers no thicker than 600 miles. Because of the shallow depth, the winds could be caused by condensing and evaporating moisture. Another mysterious question is, why is Neptune's magnetic field offset? Because Uranus and Neptune are similar in size, composition, and location, scientists believe the two planets formed in a similar manner. Uranus and Neptune also have off-kilter magnetic fields, which distinguishes them from Saturn and Jupiter, the larger gas planets. In particular, if you placed a magnet on those planets, the magnet would not line up with the center. We have no idea how you do it, Simon said, because the magnetic fields are produced by moving currents. It is assumed that all planets with magnetic fields, including Earth, have conductive material moving in their cores. Neptune's magnetic field, however, is tilted at 47 degrees to the planet's rotation, indicating that rotation and magnetism are not inherently aligned. As a result of this misalignment, Neptune's magnetosphere experiences wild variations during each rotation, NASA wrote on a Neptune page. So why does it shed more heat than it gets? Neptune, like all other planets, receives heat from the sun, but there appears to be something fierce within the planet that causes it to generate more heat than it receives. Scientists want to know why Neptune generates so much heat, because it affects the planet's weather processes, according to Simon. The temperature difference between Neptune's strong internal heat source and its frigid cloud tops, about minus 162 degrees Celsius, could trigger atmospheric instabilities that drive large-scale weather changes, NASA officials said in a statement in 2011. In the 1990s, measurements from the European Space Agency's Infrared Space Observatory revealed that the planet is radiating at minus 213 degrees Celsius, roughly 45 degrees Celsius warmer than it should be in the absence of an internal heat source. Not only this, we all might have wondered what happened to the Great Dark Spot. The Great Dark Spot is Jupiter's most famous feature and solar system's largest storm, and it has been shrinking in size for decades for reasons that are still unknown. Scientists were fascinated when they discovered a corresponding Great Dark Spot on Neptune during a flyby by Voyager 2 in 1989. Another detailed observation of Neptune occurred in 1995, when the new Hubble Space Telescope focused on the other blue planet. However, the location had mysteriously vanished by then. It could have dissipated at the equator, but scientists don't know for sure, according to Simon. Later that year, Hubble discovered what could be another dark spot. But it is difficult to tell because Neptune's photo resolution is so low at this distance from Earth. Because astronomers can't see into Neptune, it's difficult to know what its interior is made of. A 2003 model from Lunar and Planetary Institute suggests an atmosphere of hydrogen, methane, and helium. Below that atmosphere is liquid hydrogen, methane, and helium, with even lower levels of other materials including liquid hydrogen compounds, nitrogen, and oxygen. The core, if there is one, would be rocky and icy.